question number 4. Okay, this is topic EMF. Right, so before you go to topic EMF, so this one about EMF. Okay, EMF, electromotive force. What is it? It's the energy transferred or work done by an electrical source to move 1 coulomb of charge in a complete circuit. Okay, right. And then we have small letter r, which is the internal resistance. Okay, so what's internal resistance? Okay, internal resistance causes are loss of energy in dry cells. Okay, that means work has to be done to move the 1 coulomb charge against the resistance. Okay, now if we talk about EMF, you have to understand the differences between EMF and voltage. Okay, what's the difference between EMF and voltage? Okay, so EMF. Okay, look at the diagram. Alright, so we are measuring. Okay, in order to measure EMF, we use voltmeter. Okay, voltage also we use voltmeter. Now, when the voltmeter is placed across the dry cell and the switch is open. Open means in complete circuit lah, ni terbuka ni. Right? So what happened to the reading of voltmeter? So you should have done, I'm sure you have done the experiment, this one. Okay, so when this happens, that means this is in incomplete circuit, yeah? So do you think the current is flowing? No, current cannot flow because this is an incomplete circuit. However, if you observe the reading on the voltmeter, you will find the voltage is maximum. Yeah, maximum. Meaning to say, if the power supply, the battery voltage is 1.5, so you will see 1.5 there. If the power supply is 3 volt, you will see the reading is 3 volt. Okay. Now, so this is, okay, when this happens, during the switch is open in complete circuit. So when this happens, the Vmax ni, this is actually the EMF. So EMF. So EMF is the work done to bring 1 coulomb charge from terminal to terminal in a complete circuit. Now, the voltmeter is measuring voltage potential difference when the power the switch is closed. Okay, so when this happens, current is flowing. Current is flowing, so you will see the voltage drops. Yeah, the voltage drops. Why? Because there is work need to be done. There is work need to be done to overcome the resistance in the power supply, in the dry cell. Okay, so you have to understand the differences. So EMF, no current flows. So a voltage, when there is current flow. And for EMF, the voltmeter reading is an open circuit. So that is electromotive force, EMF. Okay, and this is the difference. Right, so we have that. Look at that. Now, read the question. Diagram 4.1 shows an electrical circuit of an experiment to determine the electromotive force and internal resistance of dry cells. Diagram 4.2 is a potential difference graph. Okay, so we have graph. Okay, so we have this graph when you do experiment of EMF. What is the meaning of EMF? Okay, so make sure you know, you understand. Then you would be able to write down the answer. It's very easy. EMF sama sajalah macam voltage. Okay, So it's we are talking about the work done. Work done to do what? Work done to bring 1 coulomb of charge. Sama dengan voltage, but yang tak sama dekat sini. In a complete circuit. Kalau voltage, work done to bring 1 coulomb charge from one point to another point, any point. Tapi e.m.f, complete. We are talking about the complete circuit. B, where is the suitable position of a voltmeter? The correct answer in the box. Tick the correct answer. So, where is it? X or Y? Okay, you have to understand. We want to know the work done in the dry cell, the power supply. So, it must be X. Based on diagram 4.2, okay, now we are talking about the graph. Determine the internal resistance of the tri-cell. So what you need to know, if we have this, yeah, okay, when you carry out the experiment, so this is the result. This is the graph. So from the graph, you should know there will be, and you will have maximum voltage. So that's the e.m.f. So that value is when current zero. Current zero, e.m.f ataupun voltage maximum. So that's the e.m.f. Now, so that is also the dalam mathematics lah. Kalau kita faham mathematics, that is the y-intercept. Okay, now look at the graph, the line, the pink line. Okay, dia ada gradient. Okay, dia ada gradient, and the gradient is to lower at the right part. So that means it's negative. Yeah? So kalau kita faham mathematics, y equals to mx plus c. Look at the graph. Okay, graph. Y kita adalah v. X kita adalah I. So kita just tulis macam tu lah. Dia macam ni lah. Y, v. So we write v. X axis, I. So we write I. And then we have y-intercept as the E ataupun e.m.f. Okay, and then we have gradient. Yes, we have gradient. And you should know the gradient is negative. Yeah, dia negative. Sebab dia menurun. And the value, the magnitude gives you the internal resistance. So from this graph, we rearrange the formula. We rearrange this. We can also write it this way. Okay. Plus IR. Okay. You bawa ni. Negative IR, kita bawa ke sana. Ni tinggal kat sini. Ataupun kita buat macam ni lah. So E sini. And then ni kita bawa ke sana. So that means V negatif jadi positif lah. IR. So we just rearrange. Dapat macam ni. Okay. Alright. So kita tengok balik soalan. The internal resistance. So that's easy. We can use. Okay. Kita tahu. The gradient gives you. Internal resistance equals to the gradient. You write that first. Yeah. Ni. Macam tak penting. Tapi that helps. Yeah. That helps you to think. So that helps you. Ataupun that is your you have to communicate with the examiner. But you cannot talk. So you write everything in, you know. Okay. So look at the graph. Which point do you want? So that's easy. Kita ambil point yang senang-senang lah. So this point and this point here, very direct. Okay, y-axis 3 minus 9. Ada unit tak y-axis? Ada unit? Yep. So that's the unit. So you write here. So in the end, you will not forget to write the unit. 8 minus 2. So that's the current. So you calculate, use calculator, whatever. Negative 1 V over A. So that's the unit. So you don't have to memorize the unit. You can simply write like this also correct. You just take whatever here. So that's the power of writing the unit. If you know the similar unit, it's ohm. But you don't have to remember. you don't have to memorize, yeah. Mana ni? Oh, sorry, hang on. What happened? Okay, so you don't have to memorize. You just simply write that. The e.m.f of the dry cell, you have to calculate the e.m.f around you. Do you have to calculate? No, you don't have to calculate. Yeah, but you use the graph. Use the graph and then find out what is the value. And you have to show on the graph how you get the value. So 2 marks for showing. So first, 2 marks when you extrapolate the graph. Use your ruler. You must use your ruler. Okay. Right, done. Okay. Right, so itu not yet. Kita nampak kat sini ada intercept. Okay, at 11. Right, so ni drawing this line gives you 1 mark. And then you write the value, that's another 1 mark. So it's 11 volt. Must include the unit. Okay, so very easy that one, right? Number 5, diagram 5 shows an electric stove which uses a heating element made of wire. The electric stove is labeled as 240 volt, 2 kilowatt. What is the meaning of 240 volt, 2 kilowatt? That is very important. Mesti keluar soalan tu every time, yeah. Tak ada pula dalam nota ni. Okay. Okay, so this one, the meaning is dia macam ni tau. This one is, the question asks you, what is the meaning of 2 kilowatt? So you senang je lah. What is not mentioned? So this is the power. So you ask yourself, what is the meaning of power? Power is, janganlah Uma, tu bapa pergi ubat. Power is rate of work being done ataupun rate of energy. Right? So kat sini, the value is 2 kilowatt. So what is the meaning of 2 kilowatt? So that means, okay, energy, the unit is in joule. So kita kata 2 kilojoule. Time mesti dalam unit second. So that is the meaning. Right? So it's actually similar. It's just that if you notice, I just changed the unit. If you write watt, so that means 1 watt equals to 1 joule per second. Alright? So your answer would be the stove used, electrical stove, used 2000 joule. So that's this. Tapi don't forget ada per kat bawah tu. So that's per what? What is this? Per second. 1 second, a second. Of what? Heat energy. When is that? When connected to 240 volt. What is voltage? Volt ni the unit of what? Volt. The unit of? Exactly. 240 volt potential difference. Ataupun voltage. It's very easy actually. Yeah. The electric stove is used for 5 hours per day. Calculate the energy used. So you have to know, if you want to know the unit of energy used, so this is the unit, 1 kilowatt joule. 1 kilowatt joule is 1 unit electricity. So if you have calculate the energy, you get, and you use formula P times T, so the unit is kilowatt. If the unit is not in kilowatt, you have to change first into kilowatt. Then you darabkan dengan time. But for this, for costing, the time must be in hour. Sebab our unit is 1 kilowatt hour. Ni bahasa Melayu ni, joule. Okay. Hence, this one first, you calculate the energy. Energy equals to 2. What's the formula? Energy equals to PT. So what's the power? Power is 2000 watts. Okay. How many hours? 5 hours. How many days? 30 days. Okay, berapa? Tekan calculator. That gives you kilowatt hour. Right, so if the cost for 1 unit is 20 cents, calculate the cost. That's not difficult. So that's very direct. 300 kilo unit times 0.20 cent. Okay. Okay, what's that? That is RM, 60 ringgit. Alright.
Mama bokeh-bokeh ke?
Hah?
Mama thinking ke?
Kenapa Mama cakap macam ni, Mak? Tak sukalah Mama.
Mama kek-bokeh.
Kenapa Mama cakap macam ni?
Beep, beep, beep.
Ha, Papa dah balik. Jom.